Alright, well, we'll start with the diagram of this one. Translating what it tells me here, I've got a focal length lens. I got a 32 centimeter focal length lens that's converging. And then this object out here, we'll call that P1, is located at a distance of 45 centimeters in front of that converging lens. And the height of the object is given to be 25 centimeters. Alright, and then 55 centimeters behind the converging lens is a diverging lens. Here, that guy has a focal length of minus 14 centimeters. And that distance is 55 centimeters. Okay, and we want to know where's the final image. And we want to know, I guess, the height of the final image and all that stuff. So let's see what we can do here. First we need to find Q1, right? So 1 over P1 plus 1 over Q1 is 1 over F1. So 1 over Q1 is equal to 1 over the focal length minus 1 over the object distance. Okay, so if I solve for Q1 there using that, I get Q1 is equal to 110.8 centimeters. Okay, so that's way, so Q1 is way back over here. Here's Q1. Okay, this distance from here to here is 110.8 centimeters. Well, that now Q1 is P2, right? That's the object for the second lens. That distance is 55.8 centimeters. Okay? So P2, now since P2 is behind lens 2, P2 is minus 55.8. Now remember, it's possible for that to happen. What all that means is that when the light enters this diverging lens, when you have an object distance that's negative, that just means that the light rays are converging. So that if the light was allowed to go through here unobstructed, it would eventually converge. But that number, that minus 55.8, is just telling the lens, in some sense, how fast these light rays here are converging when they hit the lens. Okay, so we can find Q2 now. 1 over Q2 is 1 over F2 minus 1 over P2, and that's 1 over negative 14 minus, well, plus 1 over 55.8. Okay, and that works out to be minus 0.0535. And so Q2 is negative 18.7. So that means Q2 is out here. That's Q2, right? That's negative 18.7. All right, so let's see if we can go through this. So for part A, the final image is 19 centimeters in front of lens 2. Or if you'd rather, you can say that it's 36 centimeters behind lens 1. That's a description of where the final image can be found, rounded off. Part B is the final image, real or virtual. Since the final image distance is negative, that tells us that it's a virtual image. All we care about is that final image distance. For part C, well, to find out if the final image is upright or inverted, we have to calculate the magnitude. So let's do that. The total magnitude is equal to the magnitude from lens 1, the magnification from lens 1 times the magnification from lens 2. So that's minus Q1 over P1 multiplied by minus Q2 over P2. Okay, so M total, let's see, Q1 is 110.8, and I'm just going to get rid of these minus signs. P1 is 45. Okay, Q2 is minus 18.7, and P2 is minus 55.8. So when we multiply all of that stuff out, we get 0.825. Okay, so that means that it is upright because the magnification is positive. Now finally, part D, it asks how tall is the final image. Well, the height of the image is 0.825 times the height of the object, which is 25 centimeters. So 0.825 times 25 is, that rounds off to 21 centimeters high.